Hey everybody, Lars here. Time for the third video for review for Unit 5. In this one, we're going to go over some extra features of object-oriented programming. We're going to look at class variables, things called deconstructors, and we're also going to look at overriding functions. But we're going to go back and do a greatest hits this video because I basically had a 24-hour day yesterday. I had to get up, go down to Trenton, College in New Jersey, and do a professional development event for Python. Then I had to give a talk. Then I had to go home, get a shower, and go play cards with my friends. And we ended up playing cards until 4 or 5 in the morning. So I am shot. I'm trying to catch up on a whole bunch of stuff. And I don't want to. Usually I would just, do the video tomorrow or do the video on Tuesday. But I don't want you guys to wait because I want to get you the assignments either later tonight or tomorrow so that you have them, you can mull over them, and then you have until December to come up with a solution, and you're going to see what I'm talking about. So I went back and I found a video from the summertime, which is really good. There's a lot of good coverage. It does everything. It does all the 3 features. Then we compartmentalize and we put our classes in libraries and we do a bunch of stuff. So watch this. Right now, the Patriots are beating the Raiders 7-0 in Mexico City. Watch this video and go to the end because I'll do some announcements at the end. I'll come back here at the end. But use this video. This video is good because it really wraps things up. It puts things all together because you're going to see classes, you're going to see inheritance, you're going to see polymorphism, and you're going to see all these extra features of OOP, and it wraps things up nicely. All right? So without further ado, here's a video from last summer. All right, see you soon. Bye. Hello, everybody. Lars here. Time to get going again with the third and final review video for Big Bad Unit 5. This video is fun. This is the video where it really feels like we're programmers. You are programmers now. You may not have sunk in, may not believe it yet, but you are. You're Python programmers now. Go get a t-shirt. Go get a mug. Do whatever it is you do when you achieve something because you are. You're Python programmers now. Congratulations. Now we just have to learn a little different way of writing some programs and move forward. We're going to take what we did in video 2 with our animal class, and then we did a cat class that inherited from it, and we're going to extend that. And I'm going to teach you some little goodies, some little tricks and extra things that come along with object-oriented programming. They're not so huge that you could do a whole lesson on them, but they're cool little add-ons that I think you're going to get a kick out of. And at the end, when we list all the stuff about OOP, you'll see it's a pretty complete toolbox that you're going to have. But let's get started because I don't want to take 5 years to get this done and bore the hell out of you watching this video. So the first thing we're going to do is we're going to bring up the code that we used yesterday. We have the animal class here with the constructor and getters and setters for name and weight. We did speak, and then we did the cat class, which inherited from animal, and we added a variable color here, and then we overrode speak. That was where we showed polymorphism. Each of the 2 things have their own speak method so that the different objects sound off differently even though the method name is the same. I ran Felix. Let's run this bad boy and see what we get over here. Felix is orange, and Felix says meow, blah, blah, blah. All right, watch this. Class cat, copy, paste, take that cat, make it say dog, come down here to self. Actually, speak I meant to say, not self. Make it say woof. Save, just that fast. We have a dog class now. So now we have a cat and we have a dog. All right, so let's get rid of that speak and let's highlight this. Copy. I'm going to come here. I'm going to paste and I'm going to say D1 equals a dog, and we'll call our dog Fido. And we'll make Fido weigh actually less than our 50-pound cat. And we'll make Fido's color brown. And I will capitalize that, and I'll actually capitalize the O, make that more complete. And then I want to come down here, and I want to make sure that C is now a D, so I get the dog's name, and we do that. Excellent. Now I'm going to create a second dog. But I'm going to grab that code because it's already got the D's in there. I'm going to paste that. I'm going to say D2 equals dog. I'll call this dog Rex. And I'll make Rex a 55-pounder. And I'll make Rex an Irish setter. I don't know if Irish setters go that big. And then I'll say D2. And then I'll say D2. All right. So now, what do we have in this little... I'm knocking my glasses off. Just as hot tonight as it was last night. Alexa, what is the weather like? Alexa. See, just like any other woman, this Alexa is finicky. Alexa, could you please tell me how the weather is?
I don't know that.
Ay, caramba. Alexa, tell me about the weather.
In Metuchen, it's 76 degrees with rain. Tonight's forecast calls for more of the same, with a low of 71 degrees.
All right, 76 isn't so bad. Yesterday was in the 80s, but still, quarter to 11 at night. 76, goodness gracious. That is bad news. All right. I've got 3 different objects now. I have my animal class. I have inherited it in a cat class. I've inherited it in a dog class. And then down here, I create 3 different objects. I don't even know if that's going to work. Let's say copy. First, let's run it. All right. Felix is orange. Fido is brown. Rex is red. Okay. So I'm just getting name and color, and that seems to all work. That's fantastic. All right. But in this particular case that we have here, Felix doesn't know anything about Fido. And Fido doesn't know anything about Rex. And Rex doesn't know anything about Felix. These objects are created with these classes, and then they're their own things. They have their own instance variables, and there's no way they can really communicate or pass information between each other. Okay? There is, and I'm about to tell you about it. What if, and this comes in handy in game programming, what if I want to keep track of all of the objects that were created using a particular class? What if I want a higher level area where I can keep track of what objects are created and destroyed with that particular class? In my case, I do video games, okay? It's nice if I have a class for an enemy or villain, and let's say it's a spider, and you're a hero in a cave, and spiders are attacking. When I create a spider, I'm just getting a spider object and having it behave how it behaves, and boom, boom, boom. But what if I want 20 spiders? Well, I'm going to instantiate 20 different spiders and have 20 different variable names. But what if I want an area where I know how many there are? So when the hero kills a spider, I know that, and I keep track of them all. There's a way to do it, and the way we do it, it's called a class variable, and I'm going to do it up here in the animal class, okay? Inside baseball. In Python, when you have a class and you use it the first time to create something, it creates an object that goes off to the side for just the class, okay? And in that space, you can have these things called class variables. And the first one we're going to do right here is really simple. The key to it is that you declare it outside of the constructor, because the constructor is for instance variables. The constructor is for those variables that are going to be specific to that object you're creating. The class variable is going to be something completely different. Now I'm going to call it a count, and in this instance I'm going to make it equal to 0. Okay? So what's going to happen when I create my first animal, cat? I'm going to want to make a count equal to 1. Okay? Now where would I do that? I could go here to the constructor of the cat and increment the variable there, but it would be smarter to do it here in the constructor of animal, because both cat and dog are going to use animal. So I could just do it once here, and because I call the animal constructor in both of those classes that inherit, it'll be run here. So what am I going to do? Very simple. I'm going to say a count plus equals 1. And I'm going to increment my variable. But there's a problem here. Okay? If I run this, it blows up. Boom. And there's a reason it blows up. It's because inside here in the constructor, it expects to deal with instance variables. And I gave it a count, and right now it's like, what the hell is a count? Even though we defined it right up there. I need to tell it it's a class variable. So I need to actually put the class name in front. Now we know the class name because we've created the class. Here we have to use self because we don't know the variable name yet. Okay, because we're creating a class for variable names as yet uncreated in the future. But here we know it because it's a class variable and we're writing the class. So I can put animal a count and then knock wood, all is well in the world and things are working again. Okay, but there's still a problem. Animal.aCount was incremented by 1, but how do we get to it, right? Well, like everything else, I'm going to write a getter for it. Don't really need a setter because of what it does. It gets set when something is created, so you don't need it. But I'm going to call it getACount self, and all it will do is return animal.aCount. And that's it. So now, when I come down here, I can say print. There are, comma, C1 dot get a count. Boom, boom. Animals. I don't need a capital there. Animals. All right, looks good. Looks good. I'm gonna copy that. Copy. All right. Now I run it. And look at that. There are 1 animals, there are 2 animals, there are 3 animals. Because when I ran cat, what is cat? C1 is a variable that holds a object that was created with the cat class. So I come up to the cat class, and what happens? I have self-name and then all that stuff with Felix and 50 and orange. And then I call the animal constructor. Okay, I come up here to the animal constructor. What happens? I set name, Felix. I set weight, 50. But here I click the animal counter. Boom. So now that variable is not 0 anymore. It's 1. And then I return to the cat class. I do the color. And then I come back here and I'm done. Now I print the name and the color. So Felix and orange. But now I print the count. And it's 1. Same with the dog. The dog comes up here. What does it do? It calls animal. So when it calls animal, I'm clicking the counter. So when I click the counter every time, it's 2, and now it's 3. Okay? Now, if you're smart, you probably noticed something. What did you notice? You probably noticed that here in these print lines, I always access it through the cat variable. You don't have to. Every one of these classes, because it used animal, has access to it. So even if I use D1 and D2 there, I'm still good and it's still the same thing. All of these different objects, C1 for Felix, D1 for Fido, and D2 for Rex, all can access that class variable. It's shared between the objects that are created with animal. So there's a way we can now keep track and share information between our objects. If we wanted to, we could create a class object where it said temp name, and I could have Felix put its name there. So then Rex could read it and say, okay, Felix left me something there. So then it's a way to what we call messaging, or it's a way for objects to talk to each other. And it comes in handy, and there's different techniques that you're going to learn further down the line. That now you've created a bunch of objects with your blueprint, but there's also a special area up in that blueprint where those objects can now trade information. All right, so now we're building a system. Now we're building some neat, cool stuff, okay? Now, and it sounds terrible because we happen to be dealing with animals here, but what if I need to get rid of one of these animals? What if I'm PETA and I need to destroy an animal? All right? There's a way to do it. Actually, it goes back to the old days, back when I learned how to program back in the 90s, 80s, 90s. There wasn't a whole lot of memory. Memory was expensive. You didn't have a whole bunch. So a big part of learning how to program was memory utilization and getting your memory back when you were done with it. So we learned when we did object orientation, C++ at first, late 80s, early 90s. And then in the mid 90s, Java came along, and a lot of people went along with Java. It was supposed to be the language of the internet. I don't know that that really panned out. But you not only had a constructor, the method that was run when an object was created, just as important, you also had the deconstructor, which is the constructor's polar opposite. It is the method that gets run when you destroy an object, when you get rid of an object. Because what we had to do when you had to get rid of an object, you wanted to recoup that memory and put it back in that area that programs use for memory because memory was scarce. Nowadays, we're lousy with memory. It's cheap. There's tons of it. You've got 16 gigs on board probably on your laptop. When I was a kid, my mother actually had to take out a loan to get me a computer with a Pentium chip in it. This is 91, 92. I think I spent $4,000 on a box with a Pentium and 8 megs of RAM. Megs, not gigs, megs of RAM. Okay? Was it some kind of, I can't even remember what I spent on that thing and what I got. I think it was a custom-made box. I don't think it was, one of the first computers I got was an AT&T facsimile, an AT&T workgroup station, 6300. Yeah, I'm digressing again. Apologies. So, now I can count my animals, okay? But that's really not any good unless I also, well, my tablet's talking to me. Something's happening. It's not the time. It's only 10:54. All right. I can keep track of the animals I create, but now how do I keep track of the animals I destroy? Well, the first thing you might be saying is, well, how do I destroy an object, There's a way to do it in Python with the keyword del, D-E-L. You can see how idle made it orange, and then just the variable name. So I'm going to destroy Felix. Oh, that sounds terrible. Okay? And then I'm going to print. Do I still have it in memory? I'm going to print their RC1, but now I'm going to get in a lot of trouble if I run this, right? Because I just destroyed an object, and then I try to use it to access the class variable. Not very clever. So I'm going to change that to D1, okay? You can do it generally with just the class in front of it, animal at this point, because we don't do a lot of things with protections. That's another story. So now if I run it, I'm going to delete C1, and I'm going to print there are 2 animals, right? No, because we didn't write our deconstructor yet, okay? It'll actually work, because inside baseball there's a super class called DEL, which will take that memory and give it all back to the program, but it won't print anything out and it won't affect our class variables. What we want to do is go up to animal and override that method. There's also one for all the dunders. We're overriding all the dunders. Now, animal. First method is the constructor, right? I usually make the last method the deconstructor. So I'm going to come down here. I'm going to say def. What am I going to do? Dunder, DEL, dunder. That's it. That's all you have to do to create a deconstructor. Now, what am I going to say here? I'm going to print. Actually, I'll say self.name, comma, has been destroyed. And then what am I going to do? I'm going to say animal. Remember, tell it what it is. Tell it it's a class variable, otherwise you'll blow up. And then minus equals 1. I'm going to decrement my counter. So now, when I come down here and I run this, it'll say 2, because I will have destroyed the animal. At least I hope so. Let's find out. Yay. So, I have Felix, there's 1 animal. Fido, 2 animals. Rex, 3 animals. Now, Felix has been destroyed with that DELC1. I think my neighbors are fighting. How fascinating. I'm going to have to call the cops. Oh, I'll keep, believe me, if I have to do that, I'll keep things running. Oh my God, it's like a zombie movie. They just laugh, they're cackling like crazy people. Oh my God, this may be my last testament. What a bunch of nuts. I didn't even know there was a big crowd. There's a huge crowd out there. They were quiet until now. Probably getting it wrong. All right, so I delete that, and what printed out? Felix has been destroyed, because that's what we set up here in our deconstructor. And then I decremented the counter so that when I print this, it now says there are 2 animals. Okay? So now animal, and I do it in animal because both of the cat and the dog inherit from animal. So what'll happen? Del C1. What is C1? C1's a variable holding an object that was created with cat class. Let me go to the cat class. Is there a dunder del dunder? I want to see if it was overridden. No, there isn't. But do I inherit from anything? Yes, I do. So I go to animal. Is there a del a dunder del dunder? Say that 10 times fast. Has something been overwritten? It turns out yes. So I use it. I print the name, self.name. In this case, Felix has been destroyed, and then I decrement my counter. Okay? If a del had not been there, it would have still been destroyed because it would have used the superclass del, but all it would have done is return the memory. All right? All I can do, that's all it can do, because it hasn't been told to do anything else. It has to do the very simplest thing. We're going to get to that in a second. Actually, we're going to get to that right now. Okay? So we got 3 things out of the way. I showed you how easy it was to just copy a class and create a dog class instead of a cat class. So we did that. We did class variables, so now our objects can talk to each other. Now we're getting complicated. We're making systems, and that's very cool. Now we know that there's a thing called a deconstructor, which is the polar opposite of the constructor. So we can now tell our program what to do when we have to get rid of objects. So if I'm in a video game, when I kill an enemy, now I can decrement my counter, and it can show on the screen that I only have 19 enemies now, not 20 anymore. Okay? So one last thing we're going to do, because I think it's pretty cool. All right, what do I have? I got 2 objects left, D1, Fido, and D2, Rex. We'll use Rex. Think about this now. I'm going to type this, print D2. Okay? What's going to happen? Think about it. If I print an integer, it prints out the integer. If I print a string, it prints out the string. What happens when I print out an object that I created? Because I wrote the class for it. I wrote the blueprint. What happens when I try to just print out a class? All right? I'm going to show you. Because I always do. Main.dogObject at blah, 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 blah. Okay, what is that? It's a, I can't leave it here because you can't see it. That's a memory location. Okay? And if you think about it, that's really all Python knows about that object, because it didn't create the class. Okay? It could do something, but I digress. I'm going to talk about it in a second. Right now, it's using a method called dunder, str_dunder, and that method resides in the superclass for animal. Why? Think about it. D2. What is D2? D2 is a variable holding an object that was created with the dog class. Dog. Is there a dunder, str_dunder? Dunder, str_dunder is what print looks for when it prints objects. That's the secret. So, is there a string, dunder string dunder here? No, there isn't. But we'll go look at animal. Animal. Is there a dunder string dunder here? No, there isn't. So what does it do? It goes to that secret Python place in the sky where the superclass is. And it uses the generic default dunder string dunder. And what does that do? It does the only really thing it can do. Give you a memory location. Because that's all it really knows about the object. Default, bland. Wow, it's pouring out there. How are they having such a big picnic out there with this rain? They are a hardy bunch. That or they got a tent. All right. So, what if I want to actually print some information? What if when I print D2, I want it to say, hey, this is Rex, and this is his color, and this is all that stuff, right? It doesn't do that, but we can make it do that. What I'm going to do, and I'm just going to do it in the animal, is right before del, because I like my deconstructor to be last, I'm going to override the string method. And the way this works is that the dunder string dunder needs to return a string. So what I usually do is I create a string. I will say a string equals, I'll say VD for variable dump. I'll tell you about that in a second. And then I can use the plus because I can concatenate strings. And I want to make sure that they're strings too. Although I think I'm not going to have a problem if I just do self.name plus put in a space because I'm concatenating, so I don't know if it'll do it for me. and then str, I'm going to cast self.weight and make sure that that is fixed. That should be good. Then I want to return a string. Okay, so now when I print D2, what is D2? It is a variable holding an object that was created with a dog class. I come up here to dog. Is there a dunder string dunder? No, but I inherited from animal, so I go up to animal. Is there a dunder string dunder? Now there is. So I create a string VD plus, and it's Rex plus whatever Rex's weight was. What was Rex's weight? We made Rex a 55-pound dog. And then we return it. So now, when I run that print D2, instead of giving us the memory location, it should say VD colon Rex 55. Well, let's find out. And it does. All right. Now, I called it a variable dump, or you could actually call it a state dump as well. Back in the 90s when I was a programmer, more C++ than Java in the early days, it was a good question. When you print an object, what should you print? Right? What if there were 20 instance variables? You print them all? A lot of times people would just print a descriptive line. This is an object for, a student in a student database. This is an object for something else. You can do that. You could also do what's called a variable dump, like I did a VD, a variable dump or a state dump. Just dump out what all of the variables are at that particular time. All right, the state of the object, basically. And some people would go even further, and they would dump out all of the variables and then list all of the methods. Almost, if you're familiar with Linux, almost like a man command, it would list out all the methods and what you could do with all those different variables. Boom, boom, boom. Okay? For our purposes, I just want to show you how to override the dunder string dunder so that when you print your objects, you print out what you want. Most of the times when I did it back in the day, I just did a variable dump. I just dumped out the state of my object. But depending on the context, what do you want to know? I mean, if you're doing a video game or you're doing something graphical and you print an object that's a flower, maybe you want to throw a graphic to the screen and show a flower, or show a zombie or show something like that. So maybe print means throw something to the screen. So it depends on the context. If you're doing something with a database that's more text-based or stuff like that, maybe you just want name, age, and, different numbers like that. It's going to be up to you as the programmer to go along and do all of that stuff, okay? So now we are really cooking with gas because now we have a bunch of different classes that all inherited from Animal. We have class variables so we can share information now, keep track of our objects. We have deconstructors. So if we need to get rid of an object like we had to euthanize poor Felix down there, we can keep track of that and reduce our number, and we can now do things when we destroy objects. And lastly, if we want to print information, we know what method to override so that when I print my object, I can write different stuff when I get rid of that object. Okay, there's one last thing I want to do, though. Let's see, source must be saved. Yes. Invalid syntax. Why? Because I hit it too. Hello. Things are going crazy. Save and run, and everything runs fine. Okay. I'm a Python programmer, right? I see this on the screen, and it kind of makes me a little kooky because I want to compartmentalize things. So what I'm going to do, and it's literally a piece of cake, is I'm going to take that, I'm going to hit copy, and this is scary. Then I'm going to hit X. Woohoo! I'm going to get rid of everything. Okay? So now I have a file with just my classes in it. Okay? Class animal, class cat, class dog. You know what I'm going to call this? I'm going to call it my animal library. And now I'm going to hit S to save. Oh, and I just saved over animals. How terrible. But I'm going to hit save as. And I'm going to call it AnimalLib.py. Okay? So now this is called AnimalLib. New file. Real fast up here, I'll just say main program for animals. What am I going to do? Control paste. Okay. I'm going to take this. I'm going to hit save as, and I'm going to save it as animain.py. So that's the main program. So now, if I run this program, what's going to happen? Well, it's going to blow up 50 ways from Sunday, okay? Because it doesn't know what cat is. What's cat? Okay? It doesn't know what those different classes are in there, all right? Because I haven't told it where to go get them. And I know I tell you not to use from, but to make everything below work, we're going to do it. From AnimalLib, import animal, cat, dog. One line. And just like that, I'm reading from my animal library. Actually, I want this to be lowercase, huh? I'm reading from my library, so I have animal, cat, and dog there. All right, great. Now, what are you realizing? Those aren't functions. We did that with functions. When we did Harshed, when we did Siete, when we did all that stuff, we were dealing with functions and, constant variables. These are classes, but you can do the same thing with classes that you did with functions. You can have them off in a library. As a matter of fact, you'll find out nowadays most things are classes, and you'll import the classes, create an object, and use the methods. And that's how you get different functionality from different libraries and things that you do. Which is why I think it's very important to have this unit in an introduction to Python programming language, especially for graduate students, because you're going to go to use a third-party library, and this is all you're going to see. You're going to see classes, and you're going to see methods in the classes, and you're going to see defined variables within the constructor, okay? That's what you guys are going to see. So then you're going to see something like this. You're going to see from AnimalLib, import animal, cat, and dog. You've got to realize those are classes. Those aren't functions. But now, when I run this, same behavior. Because I've read them all from my library. Okay? So now, think about it. We've got some pretty good stuff here. We now have a library with 3 different classes, 2 of them inherited from the big base one up here. Okay? We're creating our instance variables and using the objects that we create in a program. We show inheritance. We have polymorphism here with the 2 different speaks for dog and cat. We now have a class variable, account, that keeps track of everything. We have a deconstructor. We have overridden strings, so when we print our object, something meaningful happens. And now we've compartmentalized. We've put all of our classes in a library so that when our code, when we get our dogs and we get our cats and we get rid of things like that, it's off to the side. Our little animal library is off there to the side. So we're in pretty good shape. You got no worries, because I'm going to take Animain and I'm going to take AnimalLib and I'm going to throw them up in Sakai. So you can grab all this code and run it, play with it, change the variables, play around, try deleting D1 and then trying to get A count from it. Okay, try a whole bunch of different things. Try putting something in a loop and creating 100 objects and then put it back in a loop and delete 50 of them and things like that. Play around. That's how we learn with programming. Okay? That's it. That is your whirlwind tour of object-oriented programming. All right, everybody. Back live in person. Sunday, this is what? Sunday, November 19th. At around 5 in the afternoon, evening. It's pitch black out now. Thank you, Daylight Savings. Okay, so now you have all 3 review videos for this particular unit. You have your slides. You have the Zell readings. You have all the things you know to wrap your heads around object orientation. So either later on tonight, after the Eagles-Cowboys game, or tomorrow, when I'm in my office, I have advising hours on Mondays, I will put up the assignment. And then you'll have from then until the end of December, I forget when the unit ends, December 1st, December 3rd. I think December 1st. And I think it's December 3rd your design documents are due. But you'll have Thanksgiving break and 2 weeks to mull over your assignment. And when you see it, you're going to see, wow, this is a weird one. You got to think. You got to put your mind to things. You're going to see what's going on when I give it to you. So that's that. The boys have done a good job and gotten me both assignments and quizzes graded for Unit 4. I'm going to start putting that together and sending those grades back to you tomorrow and Tuesday. And I am still going through the midterms. There's a lot of them, so I've been running through some. Hopefully, in the middle of the week, I'll start returning them as well. Some of them are very interesting. You guys are doing a pretty good job. So that's really it for announcements. Be aware that tomorrow the proposal is due. If you take an extra day or two with it, then that's fine. But you're eating into time for your design document and your final project. So if you need an extra day for the proposal, that's fine. Go ahead and do it. All right? Then that's it for announcements. I'm going to get out of here. You be good, and I will talk to you soon. All right, bye.